All right, everyone, I am hoping that today is going to be a very quick lesson, but someone asked me a question about one of the exercises I gave you yesterday, and I think it was along the lines of log base 5 to the power of 7 or something. Do you recognize a question like this from your exercise, right? And they're like, what is that? Doesn't make any sense. Well, the idea is this, okay? So let's pretend that's the question. And they ask, tell me the answer. What do we know about logarithms if you rearrange it as an exponent? Or how will we write this as an exponent? Someone want to take a shot? Go ahead.
7 log base 5.
Okay, so base 5 as an exponent, right? So this is base 5. So the exponent is a 5.
And then 7.
Not quite.
Wait,
Careful now.
How to do it like the answer.
The other way. Okay. Log of base, okay, of the answer is equal to the exponent. Remember that? So if I were to change this back into the exponent, 5 to the power of x is equal to 5 to the power of 7. So that x is just 7. So this entire thing is just 7. Trick question. Well, not really a trick question, but it really tests. The answer is right there in front of your eyes. Do you know what the question is asking? Right? So even questions like that, can you do it without a calculator? Absolutely, if you understand what logarithm is. Please practice that for the quiz. Yes?
For some of the word problems in the textbook, they were like the answers were like decimals, so you would have to use a calculator.
You would have to use a calculator. But for this quiz, all the numbers I give you should be doable without. Okay? Case in point, since I'm recording this, I might as well give it to you. 2 to the power of 2, 4, 8, 16, 32, 64. I'm going to go so far as to say at the grade 12 level, I wouldn't put 256 past you. Okay, 2 to the power of x. You should be able to look at these numbers and be like, wait a minute, that has a base of 2. Okay, for 3, 9, 27, 81, and maybe so far as 243, any of those numbers, you should be like, wait a minute, I think that has a base of 3. At least be able to stop yourself because there's a little flag goes up in your head. 4, 16, 64, and 256. Why do I go so far in base of 4? It is because base of 4 is basically the same as 2 to the power of 2. That's to the power of x. Right? So if you could do 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 2 to the power of 8, which is the same as 2 to the power of 2 to the power of 4, which is the same as 4 to the power of 4. You should be able to do up to 256. How about 5s? 5, 25, 125. Typically, I would stop there, but hey, how do you feel about 625? I'm just saying. Numbers like that should raise a bit of a flag and say, hey, I need to slow down. This might be a thing. And even up to 6, 36, let's go one number more, 216. That might be a little unfamiliar for some of you because 6 is not a number you use too often for exponents. But up to there, I'm hoping that you're able to sort of stop yourself and slow down and be like, I think I can do something with that. All right? Any questions before I move to today? I just need to make sure I'm sharing the correct screen. It's more. Okay? All right, let's do it then. I'm going to close and move on. Transformations. For the parent function log of x, AKDC still applies, and it looks like this. A is multiplying outside the log. K and D change inside the log. It's just like logarithm. You could think about it as sine, cosine, tangent. Logarithm is a function. Whatever is inside is not something you can remove just because you want to. It's stuck to the logarithm. It's within the logarithm. Okay? And then C is the outer thing. So we're going to keep it simple. I would like to graph the function where the D value is 2 and the C value is -5. And then we'll talk about where the domain has moved from before and after, which means I am going to divvy this up. This is not a very good line, but I do it using an actual tool here. Let's divvy this up. Okay. What is the parent function? I will use dark green. If you remember, an exponent of a base of 10 is, right? So 10 to the power of 0, 10 to the power of 1, what does that equal to? When x is 0, y is 1. When x is 1, y is 10. So y-intercept is here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think because you can do your reciprocal fractions, you can sort of guess where this line is going to be. Right? That's the exponent. If you know these points, you should be able to do the reflection on the y equals x line and graph this as your parent function right away. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, yeah, 10, 1. That's a terrible line. Let's see if I can do this better. Something like that. It's a really bad line, but I hope you understand. Okay, this is log of base 10. It doesn't have to be base 10, right? It could be base 2, it could be base 3. We're going to get some practice with graphing, but for now, do you see, if you're having some trouble graphing your logarithm, do you see how you can use an exponent to help you? I hope you can, because that's how I do it for just about everything. It's easier. Okay. Let's move. I only have 2 accuracy points. Is there something else that you can logically use based on what you see in the blue line? Anything else that might help you with your stretches and your transformations and your shifts? Is it a different question?
It's kind of related.
Okay. Yeah.
Do we have to label the asymptotes?
I don't mind if you don't. However, just because we always have up till now, I think we should. And so that was basically the question I was asking. What can we use to help? Please note that there is an asymptote for the exponential function. You should know that. So if all the x's became y's and all the y's became x's, you should know, you should also expect that there is an asymptote here for your logarithm. X equals 0. Okay, let's do it. Oh, yes.
Oh, yeah, about the logical that you said, I think it's just the x and y are, like, for example, the x for that one was 0 and the other one was, I don't know, I mean, just
Zero.
the x and y will just change.
That's right. So if you have practiced a lot in grade 11, graphing your exponential, use your grade 11 skill to mentally picture what the points are on an exponential function and then swap the x and y's. Yeah, you can do that. No problem. Yes?
Wouldn't the asymptote be y equals 0? At x equals 0 in the graph?
When x equals, no, it wouldn't be true. Here, the y value could be anything, but the x value is always 0. So the asymptote would be x equals 0.
Oh, right, sorry. Yeah.
Okay, so here we go. When you have a horizontal shift, your asymptote moves as well. So instead of having the asymptote here, now your asymptote will be, let's use a really bold red line, at x equals 2. And your dot is going to move 2 to the right. This point, 10, 1, will move 2 to the right. At the same time, I am shifting down. The asymptote will also shift down. But if you shift down a vertical line, do I see a change? Of course not. Therefore, you leave that asymptote as is, and you move your point 5 down as well. So this blue dot, 2 to the right, 1, 2, 3, 4, 5. The blue dot 10, 1, 2 to the right, 1, 2, 3, 4, 5. And I'm going to leave it at that, and I want you to visualize this logarithmic curve. It has to include the asymptote, it has to go through this point, and it has to go through that point. Can you carefully sketch? I hope you can. It would look something like something like that. This is the log of base 10, x minus 2, and then minus 5. What was the domain of the original? There was x could be any real number as long as x is greater than a 0, right? For the exponential, you couldn't have a y value of 0 and below. For the logarithm, you can't have an x value less than or equal to 0. For the range, the logarithm continues to go up. It goes up slowly, but it still goes up. The range could be anything. And that sort of makes sense. For the exponential, the domain could be anything, right? So for the logarithm, the range can be anything. X-intercept. Ooh, how do we calculate the x-intercept? It's going to be somewhere far, far over here. How do we calculate that? What's the y value? Yep.
So we just plug in 0.
That's right. This is my function. Originally, if y is equal to log of x, you plug in 0 into log of x, into the y value. What x value would give you the answer 0? Use your skills from yesterday's homework. 10 to the power of exponent is x. So think about it. 10 to the power of 0 is my answer. That's right. And that makes sense. Look, right here. When y is 0, x is 1. Okay? How about the y-intercept? What am I plugging in? Log of 0. But what did we just say about the x value of 0? It's not, it doesn't exist. It's not part of the domain. So therefore, since x cannot be a 0, there's no y-intercept. And that agrees with our drawing. Look at my little blue curve. My blue logarithmic curve approaches that asymptote. It doesn't touch the y-axis. So there's no y-intercept. There's no point here. Asymptote, you say x equals 0. Now, I'm going to use red pen now to talk about how the transformations have altered the characteristics. For the domain, x still belongs to real numbers, but because my asymptote is now at 2, and the x domain has shifted, x must be greater than 2. For the range, I shifted down by 5 units, but that doesn't change my restrictions. It's still YER. For the x-intercept, remember, now we have y equals log of x minus 2 and outside minus 5. If I plugged in a 0 here, now it's not so simple. If we want to solve for x, we have to get that as alone and isolated as possible. I will bring the negative 5 to the other side by adding 5 to both. So what does this mean? How do I get x? How do I remove the x from the logarithm? You use yesterday's practice. This is the same as saying 10 to the power of 5 is equal to x minus 2. You get it? Base 10 to the power of 5 is equal to x minus 2. X is going to be 5 zeros, 1, 2, 3, 4, 100,000 plus a 2. Does that make sense? What does that mean? It means I have an x-intercept at that location. That's how far I have to go to cross the x-axis. Could you open that for her, please? All right, let's do the y-intercept. Do you see a y-intercept for the red curve? So you can try to calculate it if you want to. I'll pretend I don't know, so I will. Y is equal to log of 0 minus 2 minus 5. And if I simplify it, that is log of negative 2 minus 5. What? Log of a negative? What does that mean? If I asked you, what is this equal to? Would you be able to solve it? 10 to the power of x equals a negative 2. Thoughts? Careful, I think you're mixing it up with something. Look again. 10 to the power of x equals a negative 2. Yes?
Every exponent.
Correct. Think about the exponent once again. Every number, any x value that you plug in for an exponential does not enter the negative quadrants. This is impossible. It doesn't exist. And so, just as we stated with our domains for logarithms, if you have a 0 or negative inside there, it doesn't exist. There is no solution. Therefore, you see this log of -2, I'll put a little note on it and say this is no solution, therefore no y-intercept. And for the asymptote, x equals 2. Okay. That's the shift. And again, the stretches, it's still all the same stuff. I wonder how much time you would like me to spend here. Shall we use a different graph, like different base? Maybe that might be helpful. How about together, we change exercise 2 not as base 10, but how about we turn it into base 2? Could you add a little 2? So f of x equals 3 log 2 negative 2x. Let's solve it. To start, would you please graph the parent function of log base 2? Okay. Add your asymptote. Think about what your accuracy points of log of base 2 would be. Okay. So in blue, I'm going to do f of x is equal to log base 2 of x. Think about what that graph would look like. And in a minute, I'm going to confirm with you. I'll pause the video. Okay, without further ado, your asymptote, as you might have guessed, is still on the x-axis, and your x-intercept is going to be at 1, 0. However, think about what 2 to the power of x would look like. It would be, right? It would be 1, 2. It would be 2, 4. It would be 3, 8. And it would be 4, 16. So my logarithmic curve would be 0, 1, 2, 1, 4, 2, 8, 3, and 16, 4, which is way too far. So I'm just going to leave it at that. Once again, if it was an exponential, we would have 1, 2, 2, 4, 3, 8, 4, 16. For my logarithm, it would be 2, 1. It would be 4, 2. It would be 8, 3. And it would have been 16, 4 if I kept on going. Okay. So let me erase the exponent part. So I don't want it to be too messy. It'll be like this. There. That would be log base 2. From this point, I'm going to use green to do the transformations. Is everyone ready? Or is you need more time? We good? We good? I'll take it slow. How about I do the vertical stretch first? Long story short, I'm not going to pay too much attention to the fractions because it's a little annoying to draw. I'll start with the top numbers. The y value of 0 times 3 is still 0. A y value of 1 times 3 is 3. A y value of 2 times 3 is 6. A y value of 3 times 3 is 9. And if I had 16, 4, the y value of 4 times 3 would be 12. So this is my 3 log base 2. Everything has been multiplied by 3. And lastly, I already used dark green. Let's do a pink or hot pink or fuchsia or whatever the color is. Vertical stretch or horizontal compression. every x value that I have is essentially going to be reflected on the negative side, and it will also be divided by 2. And so my x value, which used to be positive 1, would be negative half. What used to be 2 will be negative 1. What used to be 4 will be negative 2. What used to be 8 will be negative 4. Long story short, let's see, 4, 1, 2, 3, 4, 5, 6, 7, 8. Something like here. So hey, these are nice curves. I'm pretty proud of that. Let's give credit where it's due. Okay. There it is. You can compare my domain with the blue writing on top. I am going to discuss the domain, range, x-intercept, y-intercept, and asymptote of that pink curve. Here we go. What is the domain? Well, I can now use any x value to the left of my asymptote because there was a reflection. XER, but x is less than a 0. Range, no difference. X-intercept, I could calculate it, but this time around, I'm just going to use my graph. Based on my graph, remember, I had to take a 1 divided by a 2. That x value is negative half. Would you like me to calculate it algebraically? Would it help? No? We're okay? All right, so x equals negative half. The y-intercept, did I do a phase or did I do a horizontal shift? No, does not exist. And asymptote, x equals 0 because there was no horizontal shift. Okay. That's essentially it. So as part of your exercise, I think what I want you to do, and also in preparation for the quiz, looking at random pictures or looking at random diagrams, you should be able to pinpoint characteristics, okay? The practice that you see on the back of this first page is just for you, right? There's a whole bunch of other graphing practice that you can do. Instead, I'm going to provide you with very easy kinds of questions that we can ask in the future. Take a look. All right, so again, everything that we've done, draw the parent function, do the transformations. Please make sure you don't make a silly mistake of keeping the k not factored. If I give you a situation like that, you know you have to factor. Otherwise, you make a terrible mistake of shifting to the shifting by 4. Okay? Please look at question 2 for your practice. Which graph is which? Just from looking at where the asymptote is and where the accuracy points might be, you should be able to match the equation. I'm going to give you a minute. Just give this a shot. Which one of these 4 matches these graphs? Think about this as a quiz question. Go. Okay, so questions like this, even if you are not quite sure or you're not confident in the transformation portion, a lot of it can be done through deductive reasoning, sort of like SATs. Here we go. I know that the asymptote will shift because I had a horizontal shift. If my asymptote moved to the right, I would expect my d value to be a positive. So here is x minus a positive 3. I know that this one is going to be that. Okay? Then, by the same argument, the asymptote shifted to the left by 3. The only other, I guess, function that has a horizontal shift is this one. So it sort of matches. Okay, so this one will be that. Which brings us to the question, looking at your accuracy points, which one is down, which one is up. You have this. You have that. Okay. So of course, your multiple choice questions aren't going to be this simple, but it could mix in easy ones with the hard ones for you to navigate through. So if you see certain key features that must be true based on the easy aspects, even if I added coefficients like a 4 there, or maybe I add a -3 or whatever, and I started making the functions more difficult, and I ask you those for your multiple choice, you should be able to identify and figure out the answer more quickly based on transformations that you know must happen. The asymptote with your accuracy points. Okay, and that's it. This package is thick because there's a lot of graphs that I'd like you to try. Flip through these pages for me, with me. If you look at the second piece of paper, there is one parent function that was pre-drawn for you, and then a buttload of functions that you can try graphing from part B. You don't have to do all of them, but maybe you want to do the first one, the third one, and the fifth one. I don't know. Turn the page. There is a chart with AKDC and a whole bunch of word questions. See if you can answer those questions without a graph and strictly looking at the equation itself or the function itself. That's a pretty good exercise. And lastly, the last page is a whole bunch of graphing once again. I will leave that to you. The graph itself seems a little creative because the equations look a little bit different, or rather, the functions look a little bit different than what I might have provided in our lessons. But in fact, it's still just AKDC. Maybe instead of just graphing it, you'll go through, this is the last paper. Number 2 on the bottom has functions g, h, m, n, p, s, t, and v. All the functions look a little bit funky. You don't have to graph it, but maybe you want to go through each of them and see what is k, what is a, what is d, and what is c, and confirm. Okay? And then if you want more graphing exercise, then you can actually graph it yourself. At the very last, on the very back, it says graph the following functions on the same set of axes using the appropriate transformations. Once again, do you have to do all of them? This is homework for you. You can do as many or as little as you want. That's up to you. Okay? Question?
Only like the last pages after this are
Yeah, I didn't scan these yet. I will do so right now and put it online. Okay? Yes.
We're not gonna have to do this on the quiz on Monday, right?
On the quiz, I mean, 6.3 is a part of it. I could ask you questions just on AKDC. I could ask you, show me by graphing. I could ask you, like, describe it in words. Like, all the questions you've run into up till now, it's fair game. So maybe you don't want to focus just on transformations, but you brush up, maybe do 1 or 2 just to make sure you remember it all. Yes?
The quiz is mostly to make sure we understand logarithms, right? Like pure logarithms.
Yes, I think the newest, the new skills that you have learned in 6.1, 2, and 3 is switching between exponential and logarithm and being able to solve.
And then for the test, tomorrow's lesson.
Tomorrow's lesson, so 6.4, the start of 6.4 is the beginning of the hard stuff that is included in the test, yes. Any other questions? Okay, so we've got a decent amount of time, considering it's a short day. Do what you can. If you have any questions, come and see me. Otherwise, I will upload everything and